Hi all, welcome to my YouTube channel Know About Embedded System. In today's video, we will understand how to generate interrupt from ADC. So you know that already in the previous coding part we have explained how to generate interrupt from timer. Then we have explained about PWM. Then we have explained how to generate interrupt from EWAT and SPA as well. So today we will concentrate on interrupt generation from the ADC. So before starting the video, if you are a new viewer to my channel, subscribe my YouTube channel and gain the knowledge on embedded system. Let us start the video here. So guys, ADC, you know that already, plays a very important role in our embedded system. Without ADC also it is not possible to design an embedded system. But today we will discuss how to generate interrupt from ADC. So how to generate interrupt from ADC? So now let us see here. So let us assume there is an ADC here which is connected to one of the port pin analog channel, and let us assume this is my main code here. Main code is running, but ADC is able to generate interrupt whenever the conversion is completed. You know that already. So ADC will have different analog inputs, and ADC is responsible for converting analog to digital data. And once the conversion is completed, the ADC will set one specific bit that is called end of conversion. This is also called as done bit. So two types it is called. It is called end of conversion, or also it is called as done bit. So whenever ADC generates end of conversion bit or a done bit, it is possible to generate an interrupt. So as soon there is an interrupt, so we can my processor will jump to the interrupt service routine. So we have to write an interrupt service routine for ADC, and then processor will jump to ISR, and it completes its ISR, and again it will start executing from the main program. So this is how in ADC we can generate. So as I told you guys, so ADC is able to generate the interrupt whenever the conversion is completed. You can see the blue line here. So this explains an interrupt from the ADC can be generated when the done flag is set. So whenever done flag is set or end of conversion is set in the ADC data register or ADC status register, it is possible to generate an interrupt. But before generating an interrupt, we have to enable the interrupt from ADC and also from the NVIC side. So two places we have to enable the interrupt. So first thing is, you can see here, so we have to configure. How do you configure ADC interrupt? The first thing is we have to configure ADC in a regular operating mode, such as a continuous operating mode or single time conversion. So we have to configure ADC in a proper way. That is the first point. Second point, you can see we have to enable the interrupt in two places. The second point, what you are seeing here, enable specific interrupt whenever the conversion is completed in a control register, nothing but in our case it is a NVIC, that stands for nested vector interrupt controller. We have to enable the interrupt in a NVIC side, and also we have to enable interrupt in a ADC configuration as well. So two places we have to enable. As usual, it is a regular standard rule. In the peripheral also we have to enable interrupt, and also we have to enable in the NVIC side. So whenever you enable interrupt in a both side, then third point, you can see it is possible to generate an interrupt whenever the done bit or whenever the conversion is completed. Okay, and what is the advantage of interrupt in the ADC is, so in ADC we will use a polling method. So this I'll explain in one of upcoming videos later. So we will use a polling method in ADC, EWAT, SPA. Most of the peripherals will be using a polling method, but with the help of interrupt, we can avoid this polling method. So without polling method, we can convert analog to digital, and we can read the data from the different channel. Okay, so this is the main agenda. To avoid the polling, we can also use the interrupt. Okay, so this is the theory part. So let us go back to the coding, and I will show you how we have written the code and how it works. So coding is not complicated, but one thing is you have to watch my previous ADC video. If you do not watch my previous ADC programming video, it's very difficult to understand this coding. So that's why I will update the link in my description box. You can go and watch my ADC programming video. So there in detailed way I have explained what is the ADC, and how we have to develop the coding. So almost 30 minutes video I have made. You go and watch that video. You will understand how we have developed the coding for ADC. But here in this coding, in today's session, I will not explain that part of the coding. Instead, I will explain only the part of the interrupt here. So now this is the coding which already we have done in the previous videos. So you know that these are all the function selection, nothing but port pin function selection, and I'm using analog input channel number 2. AIN stands for analog input channel number 2, and which is connected to P0.25. And these are all my pin function selection macros, and these are all my ADC configuration macros. One is a clock division, PDN, burst mode, channel selection 0, 1, 2, 3, then ADC result, then done bit, then analog power enable for the ADC. Okay, so these are all the macros, and here you can see the important thing, two important things I need to explain in today's video. The first thing is ADC configuration along with interrupt enable. So this particular function, what you are seeing, this is completely analog to digital configuration, and in detail again I have already uploaded a video. You can go and watch there. Link I'll update in the description box. So this line number 48 is used to enable the power, and then line number 50 is used to select the appropriate function of your analog input, the line number 50. Then line number 53, so here you can see this is actually the analog ADC proper configuration, where we're going to configure my channel number, and I'm going to configure the clock value on a ADC clock division value. Then I'm going to enable burst mode, and then I'm going to enable power down mode. Okay, this is actual main ADC configuration. So yeah, so our interrupt part lies here, line number 55 and 56. Here you can see. So this is an additional thing where I'm going to enable interrupt in ADC part, bit number 8 and bit number 2. So this I'll explain in the data sheet as well. So bit number 2 and bit number 8 I need to go. I'll just open my user manual. Here you can see this is in this register we have to configure an interrupt from the ADC side. Okay, so I'm going to use channel number 2 here, ADC interrupt enable. Here how many channels are there? Those many interrupt enable bits they have given. In my microcontroller I have 8 analog inputs are there. That is why, so they have totally given 8 bit fields here, bit number 02 and bit number 7, and then they have also given one ADC global interrupt enable, bit number 8. This bit number 8, what you are seeing here, this is called as global interrupt enable bit. We have to enable global interrupt enable as well. So in the coding, since I'm using channel number 2 in my coding, I'm going to use channel number 2. I need to use bit number 2 here. Enable bit number 2 to activate interrupt from ADC. This is the first point I need to do. The second point is I need to enable ADC global interrupt enable. So both we have to enable to generate interrupt, bit number 2 and bit number 8. So this is what I have already done in the coding. Here you can see. So bit number 2 and bit number 8. Bit number 2 and bit number 8. So bit number 8 is nothing but global ADC global interrupt enable, and bit number 2 is ADC channel number 2 interrupt. So this is an additional thing compared to previous programming. And second additional thing is, as usual, we have to enable interrupt in the NVIC side as well. And I need to mention what type of peripheral I'm using. NVIC enable IRQ. This is going to enable the interrupt of your particular peripheral. And my peripheral today is ADC here, ADC underscore IRQ. And then I need to set the priority here. So these two are additional things with respect to ADC interrupt generation, only two important things. And one more third important thing is handler. Here you can see this is my handler. So in the handler, what we have to do. So what is the advantage of interrupt is, I'll just go back to the slide here. One point I have kept it, avoid polling. You can see the last point, whatever here. Okay, so what in a regular programming we have done, we have done polling method. In the regular programming, we have used a polling method. So we have used polling method. In the polling method, continuously we were polling done bit. We were polling continuously done bit. Continuously we were monitoring bit number 31. That is called a done bit. But in this video or in this programming, we don't use that. We don't use a polling method, because if you see here, see, this is my main code, and this is my ADC configuration, and this is my handler. So I have only two functions today. One is ADC configuration and one is a ADC handler function, and there is no any ADC data. There is no ADC data function, and I'm not reading any data from the polling method. Okay, so that's why I told you what is the use of interrupt. With the help of interrupt, we can avoid unwanted waiting period, which is going to waste in the polling method. So here, so coming back to the topic, so this is my ADC handler here, and here what I'm doing is the first thing is, as soon there is an interrupt or whenever there is a done bit is set, the processor will come to the ADC handler function, and here you can see it is going to read ADC status register. So we have to read a ADC status register in order to clear the interrupt. Okay, so we have to clear the interrupt as soon you enter into the service routine or before leaving the interrupt service routine. So here I am reading the status register to clear the interrupt. This is the second point, and third and fourth points are same to the previous programming. There is no difference here. After that, I'm just reading a data from the ADC data register. Here you can see the extracted digital data from the ADC data register. Exactly whatever we have done in the previous code, same thing, but without polling. We don't use any polling method here. So here I'm reading a data and right shifting by 4 position to get it as an LSB, and then I'm printing on the terminal. The line number 76 is used to print and give small delay and then go to the next line. Okay, so this much interrupt handler function. Okay, so important thing is interrupt generation, and read the interrupt status, read the ADC data, and print it on the terminal. So this is my ADC interrupt service routine, but in the main code I'm doing one small action. You can see here the line number 40. I'm just toggling one port pin whenever there is no interrupt or whenever there is no ADC conversion. Whenever there is no conversion, I'm going to toggle P0.0 as a main program. So this is my main program. Whenever there is no conversion or whenever there is no data, I'll be toggling P0.0. Okay, so this is the code. Now I have already compiled. Let us go and check output in our window. Yeah, so I have kept it everything ready. Yeah, this is your ADC converter. So let us just run it first. I'll tell you one by one. Here you can see. So I have made the selection 4. Selection 4 is nothing but channel number 2. This is a PDN bit, burst mode. Clock division 17, nothing but 23 it is. Then ADC clock is generating with a 1 megahertz clock. And yeah, these are all the configurations I have already explained. So now our scope here. Here you can see in the scope of this. So I have enabled ADC global interrupt enable, and then ADC global interrupt enable. Then I have also enabled the channel number 2, interrupt from channel number 2. Both I have enabled. Okay, so now what I will do, I need to assign the inputs in analog input channel number 2. So in this channel I have to assign input to the ADC channel number 2. Let us give some value here and let us check whether will it work or not. Yeah, now you can see. So it is printing in a ISR. Okay, the ADC is printing in the ISR part, nothing but ADC interrupt handler part. Here you can see. So I'm reading a data, and here I'm reading a data. Line number 72, I'm reading a data and then printing in the your terminal. Okay, So it is showing as 120. I will just give some more value here, something called 0.3 I'll give. Let us see what will happen. Now you can see it is printing 372, right? So it is printing 372, and still I'll give 1.3. Let us check what will happen. Now you can see it is printing 1613. Okay, so now it is printing in ISR. The conversion, whatever you are seeing here in your terminal, this is in ISR. Now what I will do, I'll disable ADC global data, global interrupt, and then also I will disable my channel number 2 interrupt. Now you observe GPIO 0.0, it is toggling. That means this code. Line number 40. Here you can see line number 40 is executing. Why? Because I have disabled ADC interrupt channel number 2 and global interrupt both. And you can see here in the AWAT it is not printing anything, but instead it is your controller is executing the main code. So, okay, so observe here this bit number 0 is printing. It is toggling, it's not printing. So now what I'll do now, I'll just enable ADC channel number 2 here, and then I'll enable the global interrupt, and now you can see, so it is printing. I'll change the value here, 2 I'll give, and we will check the output. Correct, right? So that means whenever there is an analog input is coming, then the processor will execute ISR and it will convert and it will display. And whenever there is no analog input, it will execute your main code. That means whenever there is an interrupt, processor will execute ISR, and whenever there is no input, it will execute your main code. So currently the main code is executing, and whenever I enable interrupt, so it is going to print your ISR. It's going to execute your ISR. So in this way, you can configure interrupt for ADC. You can generate interrupt from the done bit, and then you can jump to ISR. And whenever there is no analog input, the processor will execute your main code. I hope this video is clear. If you feel this video is an informative video, please click on like button and subscribe to my YouTube channel.